Hello and welcome to our last chapter. We're only going to do 3 sections in this chapter, 1, 2, and 3. The first part is about distance and linear motion and understanding how integrals and derivatives work in that. A lot of these things you have already seen, but we're going to kind of bring it all together today, and this is very often seen on the AP test. So let's talk about the definitions of different words. An integral, 7.1 is talking about an integral is net change, and we talk about linear motion again. Velocity functions describe the motion, and as I've said before, you often, I can't draw a straight line, you often see the position function written as an integral of velocity, and often the velocity is the graph they give you. So you have to think of the derivative graph as being shown. And when velocity is positive, the particle is moving right. When it's negative, moving left. When it's 0, it's stopped. Displacement is the net area. Don't get that confused with the total distance, which is how far the area actually between the curve and the x-axis or the t-axis. Okay, at this point we're looking at a graph that has velocity on one axis and time on the other, usually. The final position is wherever it starts plus the displacement, which is the net area, and then the acceleration would be the area under the curve of the, the derivative of the velocity. That would be the acceleration. Okay, so those are all a little review. So let's see how they work in a problem. We're going to do 2 problems from your assignment. The first one is number 2. It says describe the motion of this function, 6 sine 3t. I've graphed it over here on a graph. It's above the x-axis. The velocity is above the x-axis until t equals pi over 3. And then it goes down to -6 at pi over 2. So the motion then is to the right or above the x-axis from 0 to pi over 3. And then it's to the left from pi over 3 to pi over 2. Okay, and note that this is on a closed interval, so that makes a difference. The next question is to find the displacement in the time interval and find the final position. So this is 2 questions. First of all, to find the displacement, you take s and go from 0 to pi over 2 of the derivative curve, which is 6 sine 3t. And the area under that curve will give you the displacement. And you take the antiderivative of this, -6 if you use the u substitution on 3t, you get -6 over 3 times cosine of 3t. We evaluate that from 0 to pi over 2, and we get -2 -2 cosine 3t from 0 to pi over 2. It's supposed to be a -2. So -2 cosine of 3 pi over 2 minus cosine, -2 cosine of 0. All right, so to evaluate that, we get 0 minus -2, which equals 2. So our displacement, because cosine of 0 is 1, 3 pi over 2 cosine is 0. So we get displacement is 2. And that's the answer to the first question. The final position is wherever we started. And they said at t equals 0, the position is 3, plus our displacement, so the final position would be 5. The next question is total distance traveled. Now notice, between 0 and pi over 3, you're above the line, and pi over 3 to 2, you're below the line. So all we're going to do is take the antiderivative from 0 to pi over 3, and then add the position absolute value of from pi over 3 to pi over 2. Okay, so we have 6 sine of 3t dt, 6 sine 3t dt. Okay, and if you go ahead and evaluate this, yeah, I forgot to erase all this. So if you do this, you get 2 minus -2 plus 0 minus a -2. All right, so you should get 4 plus 2 and get 6 for your final answer. All right, you would have to take the derivative, take the antiderivative at pi over 3 minus 0, take the antiderivative, which we took earlier, at pi over 2, subtract pi over 3, antiderivative, and you should get this. Okay, the next problem is number 20. There is a graph in the book. I've kind of copied it over here. There are just 2 questions on this problem, so we can answer them one at a time. Where is the particle at the end of the trip? Okay, so first of all, the particle starts at 2 at the beginning of the trip. So we know we start at 2. Then we're going to add the areas of A minus the area of B plus the area of C, because A and C are above the line, B is below the line. So I've partitioned off the 3 areas into 3 different categories. So 2 again is our beginning position, and that was given to us in the problem. So always look for a beginning position or an initial value. This could also be written as 2, and this is how you'll see it on AP test solutions. They'll write it like this. 2 plus the antiderivative, or the area under the curve, from 0 to 10. But what you're really going to do is add the areas, like I wrote above that. So let's look at and evaluate what those are. We have 2, we have the area of A, which is 1/2 base times height. The base looks like 2, the height is 3, so that's A. B is the area of a trapezoid. 1/2, 5 plus 3 are the 2 bases, and 3 is the height. So that's the area of B that we subtract. Then we're going to add the area of C, which is 1/2, 3 times 3, 1/2 base times height. Okay, those are our 3 areas. If we add them together, we should get 2 plus 3 minus 12 plus 4.5. And that should equal -2.5. If I've added those correctly. Yep, that looks pretty good. That's supposed to be a -2.5. Okay, the last question on this problem is, what is the total distance traveled? Okay, so the total distance traveled is just A plus B plus C. Since we've already figured out what each of those are, this is A, this is B, this is C, we're just gonna add them together. We used to redo that whole thing. A plus B plus C, and that gives you 19.5. And actually, if we were really being diligent, and often you get a point for using units, you should be putting down meters, because in this problem, they gave you the units. So when you do this in your assignment, if they do give you units, use them. Often you get a point for it on the AP test, which is a lot. So there you have it. That's section 7.1, day 1.